World and welcome. Today we'll talk about um, classification of some input data. In this case, we have some pictures, some random pictures, as you can see here, which are going to be classified within 10 classes. So that's why we are using convolutional neural nets on the Cifar 10 dataset, which you can also find everywhere basically. And you don't even need to download it. You can just use it by access the data with a link, and then you can just import the data and classify the pictures here. My name is Harris, and let's get started. So if you like this content, please hit the subscribe button or leave a like comment there. Thanks a lot. First of all, we are going to import the libraries here. As you can see, I'm importing the MNIST dataset, also the Cifar for, in this case, I'm using Keras as well as TensorFlow to just setting up convolutional neural net. First of all, I'm loading the Cifar 10 data here with the load data function to just see how this data looks like. As you can see here by using the imshow method, you can just see that there are some arbitrary data, some arbitrary pictures from horses, from a truck, from a ship, and so on. And you can just basically see it, the labels here. We have 10 different classes, and you can label it from 0 to 9. Afterwards, I'm going to shape everything because it's really important that they have pixel 32 by 32 channels. There are 3 channels because it's a colorful picture. So we have blue, red, and green in this case, 50,000 data sets, and we are going to just predict. For instance, we have a horse here. We're going to predict and classify these input pictures. So we are shaping everything we are dividing everything by 255. To normalize everything, we are doing one-hot encoding, and then I'm setting up the model here, right? So you have 2-dimensional convolution layers because we have pictures here. And first of all, I'm using convolutional layer. Afterwards, there you can see the max pooling layer to just resize everything to make the picture a little bit smaller, the resolution, and I'm flattening everything afterwards to just have it in one vector. And then I'm applying 2 dense layers, and afterwards dense layers with 10 outputs because we have 10 classes. So I'm using here the SGD optimizer with a momentum of 0.9, categorical cross entropy as loss because we are basically classifying pictures here, 10 categories. You can see there are more than a million parameters or weights in this case. Then I'm fitting everything basically only with 10 epochs. And then you can see that you can use 100,000 epochs as you like to make the model even more precise. In this case, you can also save the model here and to reuse it again after a while. You can see the model accuracy here, it's getting up, and as well as the model loss, it's decreasing after some epochs. Then I'm doing really the basic part here. As you can see, the prediction. I'm trying to predict the last 10 pictures here. In the middle, something like this. So I'm basically just picking 10 pictures. And then you can see here the actual label 857 and so on, and the predicted, what the model was predicting. It's mostly actually fine. So we have accuracy around about, let's see here, around about 89%. After 10 epochs, it's basically okay. You can achieve 90, 96, 98, even more after more setting up a better model with more parameters and with more epochs, and then you can achieve even more accuracy. But we have basically a fine accuracy here. As you can see here, he was predicting number 8 as well. So the ship, we have label number 5, which is in this case a dog. And a horse, and so on and so on. So you can basically see he was predicting pretty fine after only 10 epochs, which is really nice. So I really like it. And you can see the power of convolutional neural right now here again. So if you want to see more tutorials, hit the subscribe button or leave a like, comment there. Thanks a lot for watching, guys. See you soon.